This is the solution of JEE Mains Paper 3 Chemistry. Question number 61. Benzene is reacting with allyl chloride in presence of AlCl3. AlCl3 is an electron deficient. It will attract the Cl and it is converted into AlCl4 minus and it is converted into an electrophile. Now this electrophile will react with benzene as an electrophilic substitution reaction. So we can write it is converted into AlCl4 minus, that means Cl is attracted toward AlCl3. Now it is converted into electrophile and that electrophile is now this electrophile will attack to the benzene as an electrophilic substitution reaction. Double bond will attack. After that, removal of H plus and it is converted into this compound. The next step is it is reacting with BH3 in presence of THF followed by H2O2 in presence of OH minus, that means alkaline medium. Now the function of BH3, it will always provide primary alcohol, or we can say less substituted alcohol. So in this case it will provide 1 degree alcohol, it is the less substituted, so it is converted into 1 degree alcohol. So we can write the next step, it is reacting with HF first of all elimination of water molecules, that again it is converted into an electrophile and it will go for electrophilic substitution reaction and it is converted into a cyclic compound, and means we can say this H plus will attack to OH minus and there is a removal of water molecule, there is an electrophile form and it is again electrophilic substitution reaction, and the end result is now if you check the all four options, it matches with the option C. So for the answer is option C. Question number 62. We have to convert this, that is nitrobenzene, into this compound. So first of all, we can use Br2 in presence of FeBr3. Since nitro group is an electron withdrawing group, so it will prefer meta position bromine. So it is act as an electrophilic substitution again, and since nitro group is a metal directing group, it is converted into Pr. Then again, now we have to convert this NO2 group into NH2 so that we can add. For that we have to reduce this nitro group into NH2 group. So we can use the reagent Sn in presence of HCl. That means Sn will react with chlorine to form SnCl2 and it will liberate nascent hydrogen. That means we can write this as reaction SnCl2 plus nascent hydrogen, and this nascent hydrogen will reduce nitro group into NH2 group and it is converted into NH2 and Br. Now we have to convert this NH2 into I group. So we can use NaNO2 plus HCl in N followed by Ki. So this NH2 group is converted into iodine. So we can write and it is matches with the option C. So again the answer is option C. Now question number 63. Methyl cyanide is reacting with ethyl alcohol and sodium. Now this react together. First of all these two react. That is C2H5OH plus Na. Product is C2H5ONa plus nascent hydrogen. Means it will produces nascent hydrogen and nascent hydrogen will reduce CH3Cn. So we can write CH3Cn reduced by nascent hydrogen and converted into ethylamine. Again I am repeating, it is methyl cyanide, it is reduced by nascent hydrogen and it is converted into ethylamine. Now it is further reacting with HNO2. We all know that if it is reacting with HNO2, this NH2 group is converted into alcohol. That means ethylamine will be converted into ethyl alcohol. Next, we are using nascent oxygen. That means nascent oxygen will further convert alcohol first into aldehyde, then into acid. That means ethyl alcohol will be converted into acetic acid. So using nascent oxygen, it is converted into CH3COH. Acetic acid. So answer is option C. Question number 64. Out of these four, which one will be hydrolyzed faster? Hydrolyzed faster means SN1 reaction. SN1 reaction will be preferred by benzylic carbon. So since this Cl can be removed and it is converted into benzylic carbocation, so the option A is the correct answer. So we can write, since it is a benzylic carbocation, option A will be hydrolyzed faster rate. Question number 65. The compound is given and the reagent is LiAlH4. LiAlH4 acts as a reducing agent. It produces nascent hydrogen and it will reduce this compound. Now this compound contains two functional groups. One functional group, that is ether, another functional group is ester. There are two ether groups and one ester group is present. LiAlH4 reduces ester group, but there will be no effect on ethers. That means ethers will not be reduced by LiAlH4. So the resulting product is that means only this ester is reduced into alcohol, but there is no effect on ethers, and therefore the option is D. Question number 66. There are two keto groups are present. These are the two keto groups. They are electron withdrawing groups, and in presence of NaOH it will go for intramolecular aldol condensation. So we can write it will go intramolecular aldol condensation. These two keto groups both are electron withdrawing groups. These two are electron withdrawing group. So these hydrogens, that means these are the alpha hydrogens which are present. They are active hydrogens, and also we can say it is acidic hydrogens due to the presence of these two electron withdrawing group. Now in presence of NaOH, one of the hydrogen will be removed. These two hydrogens are active hydrogens in presence of NaOH. That means we can write OH minus. It will remove one of the H plus ion so that it is converted into H2O. So it is changes into a carb anion. So we can write this. Now this carb anion can attack to this carbonyl compound. Since oxygen is more electronegative, so this minus will attack to this carbon, due to which there will be a bicyclo compound will form. Now this is the bicyclo compound. Now in presence of water it will accept this H plus ion and it is converted into alcohol. So H2O, one of the H plus will be attached to O minus and it is converted into alcohol. So we can write now further on heating, since heat is given, there is a elimination of water molecules and it is converted into an alkene. Due to the removal of this OH and H, it is converted into a double bond. So the answer is option C. Now question number 67. Acetone is given and we have to find the number of sigma bonds, pi bonds and lone pair present in enolic form of acetone. So first of all we have to draw the enolic form of acetone. So this is the enolic form of acetone. This is the enolic form of acetone. Now in this we have to find the number of sigma bonds and pi bonds and lone pair. Therefore we have to draw the structure. So we can count number of sigma bonds first. 1, 2, 3, 4, 5, 6, 7, 8, 9 sigma bonds are present. So you can write 9 sigma bonds. Next pi bonds, only one pi bond since there is only one double bond. So you can write 1 pi bond. And number of lone pairs, since oxygen contains 2 lone pairs, so we can write 2 lone pairs. That means the answer is 9 sigma bond, 1 pi bond and 2 lone pairs. Therefore, it is option A. Now question number 68. Benzaldehyde is given as a reactant. There are two molecules of benzaldehyde. It is reacting in presence of OH minus and product is benzyl alcohol and benzenoid ion. Now we have to find which one is the rate determining step in the mechanism. It is a Cannizzaro reaction. So only I am writing the rate determining step. Now this oxygen containing negative charge will be converted into double bond and the removal of this hydride ion and it is transferred to this carbonyl group. This is known as a rate determining step of the Cannizzaro reaction. So we can write transfer of hydride ion to carbonyl group is the rate determining step. Therefore the answer is option C. Now question number 69. We have to convert butane to ONA into propanoic acid. So we have to remove this CH3 group, means in this case it contains 4 carbon, in this case it contains 3 carbon. So we can use haloform reaction to convert this. Haloform reaction, NaOH that means NaOH and I2 in presence of H plus ion. So we can write this CH3 CH2 C double bond O CH3. These 3 hydrogens are known as the alpha hydrogens. When it reacts with NaOH in presence of I2 and H plus, it is converted into propanoic acid and CHI3. Therefore, the answer is option C. Now question number 70. Given is CaO is completely neutralizing with P4O10. That means CaO is reacting with P4O10 and it is converted into calcium phosphate. We have to find the amount of CaO required to completely neutralize with 852 gram of P4O10. First of all, convert how many moles of P4O10 is present. Then balance this reaction. The reaction is 6 CaO reacts with P4O10 and product is 3 Ca3PO4 whole 2. Now number of moles you can find. Number of moles present is weight given is 852. Molecular weight of P4O10 you can calculate 4 into 31 plus 10 into 16. That means we can write 4 into 31 plus 10 into 16. That is equal to, now you can calculate, you will get 3 moles. That means 3 moles of P4O10 is present. If 3 moles of P4O10 is present, then it requires 6 times of it. That means we can write 6 into 3, that is 18 moles of CaO required. So we have to find the weight. We can multiply with the molecular weight of CaO. Molecular weight of CaO is 56. So we can write weight required is equal to 18 into molecular weight of CaO, that is 56. Calculate this, you will get the answer, and that is option B. Now question number 71. Which of the following will show optical isomers? For optical isomers, it should contain a chiral center, or we can say it should be dissymmetry. So there are 4 compounds are there, all containing double bonds, so we can say it will show geometrical isomers, but we have to find the optical isomers. So you can check this one. The carbon is attached with 4 different groups, so we can say it is a chiral center. So if it is a chiral center and it is a dissymmetry, that means it do not contain any plane of symmetry and center of symmetry, we can say it is an optically active compound, but in all the rest 3 it is geometrical isomers. So we can say option A is the correct answer. Now question number 72. Phenol will not react with which of the following? The 4 given is sodium bicarbonate, sodium hydroxide, potassium hydroxide and ferric chloride. Now this phenol can react with sodium hydroxide and it is converted into ONA, as an acid is reacting with base. In the same way it can react with an acid as a base, and this is FeCl3 is an electron deficient, so oxygen can donate its lone pair, so it will also react with ferric chloride, but it will not react with sodium bicarbonates. So we can say answer is option A. That means phenol will not react with sodium bicarbonate. Now question number 73. Arrhenius equation we can write on the basis of Arrhenius equation, K1 is equal to A1 e to the power minus A1 by RT. In the same way, for the different reaction, we can write K2 is equal to A2 e to the power minus A2 by RT. Now in the question it is given that rate constant K1 is the twice of the rate constant K2, and we have to find the relation between E1 and E2. Since we know that K1 and K2, the ratio is given, that is K1 by K2, we can write 2:1. So we can write K1 by K2 is equal to A1 e to the power minus E1 by RT and A2 E1 e to the power minus E2 by RT. The ratio of K1 by K2 we can write 2. But in this case, Arrhenius parameter A1 and A2 is not given. If the ratio of A1 and A2 is unknown, then we cannot predict the ratio between E1 and E2, or we cannot find the relation between E1 and E2. Therefore, we cannot predict this answer. Therefore, the answer is option D. Question number 74. There are 4 gases: helium gas, CO2 gas, NH3 gas and SO2 gas. And we have to find which of the gas is liquefies very difficult. Which gas is difficult to liquefy. Now this CO2 gas, NH3 gas and SO2 gas can be liquefied easily. But if you consider helium gas, due to its low molecular weight and small size and so low critical temperature, it is very difficult to liquefy helium gas. So we can write its low molecular weight, low critical temperature and difficult to polarized. These are the 3 conditions: low molecular weight, low critical temperature and difficult to polarize the helium atoms. It is difficult to liquefy. Therefore, the answer is option A. Ag plus, CO2 plus and Al3 plus all are arranged in series, and on passing 3 Faraday of electricity, what molar ratio of Ag plus, CO2 plus and Al3 beta ions will form? Since we passed 3 Faraday, so we can say that 3 moles of Ag will form, Ag beta ions. And if we consider copper, since it contains Cu2 plus, so it will produces 3 by 2 moles, and Al3 plus will produces 1 mole. So the ratio is 6:3:2. That is option D. That means it is in the ratio 6:3:2. So answer is option. Question number 76. A cube is present in which it contains A atoms in abscissa arrangement. B occupies all the tetrahedral voids of it. A density of A is given 1 gram per cc and its molecular weight is given A is 30 and molecular weight of B is given 50. We have to find the density of the resulting solid in gram per cc. So we can write density is equal to, since it is FCC arrangement, we can write 4 into molecular weight of A is 30, Na Avogadro number of molecules. Let us assume the volume of the cube is V. V is the volume of the cube. The density of B Since it is in tetrahedral voids, we can write 8. Molecular weight is 50 Na into volume V. Now this is the equation 1, this is the equation 2. On dividing equation 1 by 2, we can get density of A by density of B is equal to 0.3. On cancelling this all things, we will get 0.3. Now the ratio is 0.3 and we know the value of density, that is A is 1 gram per cc. So we can write 1 by rho B is equal to 0.3. Therefore density of B is equal to 1 by 0.3, that is equal to 3.33. And the total density is equal to density of A plus density of B. So we can write resulting density of the solid is equal to density of A plus density of B. We can write resulting density of solid is equal to density of A plus density of B. Density of A is 1 and B is 3.33. Therefore it is 4.33 gram per cc and it is option B. Question number 77. According to Freundlich, x by m is equal to k into p to the power 1 by n. We have to find the slope of this if we draw a straight line. So first of all, take log in both sides. So taking log in both sides, we will get log x by m is equal to log k plus 1 by n log p. If we consider straight line y is equal to mx plus c, so we can write y is equal to mx. We have to draw a straight line between log xm and log p. So y is equal to mx plus c is for the straight line, then m is the slope. Now if we equate equation 1 and 2, we will get m is equal to 1 by n. So we can write slope of this equation is equal to 1 by n. Therefore answer is option A. Question number 78. Weight of the sucrose plus weight of the water is given 100 gram. That means sucrose solution in water weight is 100 gram and Kf value is given 1.86 and molecular weight of sucrose is 342 and del Tf value is given 0.38. So we know that del Tf is equal to 1000 into Kf into W into molecular weight of solute. So del Tf value is given 0.38, so we can write 0.38 is equal to 1000. Kf value is given 1.86 and molecular weight of solute, that is sucrose, it is given 342. On solving this, we will get W by W is equal to 0.07. This is the equation 1 and we know that weight of the sucrose plus weight of the water is 100 grams. So we can write W by capital W is equal to 100 So we can write this is equation 2. On solving these two equations, we can find the value of W, and that is weight of the sucrose, and also the weight of the water present in it. So on solving, we can find W is equal to 6.6 grams. That means 6.6 gram of sucrose is present. So we can find the weight of the water. The weight of the water is 100 minus 6.6, that is equal to 93.6 grams. Now weight is 6.6 gram, weight of the sucrose, and weight of the water is 93.4 gram. Initially delta F value is 0.38, now it is changes to 0.5. That means some water has been converted into ice and it is separated out, and we have to find that amount of ice which is separated out. Since sucrose is a solute, it remains same, only the weight of the water, that is the solvent, will be changes. So we can use this value delta F1 is equal to 1000 into Kf into W, that is weight of the solute by weight of the solvent, that is new solvent H2O, into molecular weight of sucrose. Delta F1 value is 0.5, so we can write 0.5, that is equal to 1000. Kf value remains same, so we can write 1.86. Weight of the sucrose remains same, that is 6.6. We have to find the weight of water. Molecular weight of sucrose is 342. On solving this, we can find the weight of H2O, the new H2O, and that is equal to weight of H2O is equal to 71.78 gram. Initially it was 93.4, now it is 71.78. That means if we subtract this, we can find the amount of ice which is separated out. So we can write weight of ice is equal to 93.4 minus 71.78, that is equal to 21.62 gram. That means 21.62 gram of ice will be separated out. Therefore the option is C. Therefore answer is C. Question number 79. Given number of moles is 5, temperature 27 degrees Celsius, that means in Kelvin it is 300 Kelvin, and V1 and V2 given is 6 liters and 60 liters respectively. R value, we all know that R value is 8.314, and it is an isothermal and reversible process, and we have to find the work done. So we all know that work done is equal to minus 2.303 nRT log V2 by V1. So we can put up this value. W is equal to minus 2.303 nRT log V2 by V1. Putting all the values, we can write minus 2.303, N value is given 5, R value is 8.314, temperature is given 300 log 60 by 6. On calculating, we will get the work done, that is equal to minus 28.72 kilojoule. Therefore the answer is option B. Question number 80. We have to compare the rate of diffusion of hydrogen gas with the helium gas. So first of all, we have to write rate of diffusion is inversely proportional to the square root of its molecular weight. So we can write we can compare between two different gases. So we can write rate of hydrogen gas by rate of helium gas is equal to molecular weight of helium by molecular weight of hydrogen gas. Molecular weight of helium is 4 and hydrogen gas is 2, so we can write is equal to 4 by 2, that is equal to 1.4. That means rate of hydrogen gas is 1.4 times of the rate of helium gas. So the answer is option B. Question number 81. A mixture of potassium carbonate and lithium carbonate is present and its mixture weight is given 0.5 gram. We have to find the percentage of Li2CO3 present in the mixture. Given that it is completely neutralizing with 30 ml of 0.25 normality HCl. Molecular weight of K2CO3 is 138. Molecular weight of Li2CO3 is 74. So let us assume that the weight of K2CO3 is present is A and the weight of Li2CO3 present is B, and the mixture weight is given 0.5, so we can write A plus B is given 0.5. This is the first equation. Now since it is completely neutralizing with 30 ml of 0.25 normality HCl, so we can write weight is given A, its molecular weight is 138, by its N factor is 2 into 1000 plus Li2CO3 weight is B, its molecular weight is 74 by 2 into 1000, and this is completely neutralizing with 30 ml, so we can write is equal to 30 into 0.25. This is the equation 2. On solving these two equations, we get A is equal to 0.48 and B is equal to 0.02. Now we have to find the percentage of Li2CO3 present in the mixture. So we can write 0.02 by the total weight is 0.5 into 100. On calculating we will get 4%. That means 4% of Li2CO3 is present in the mixture. Therefore the answer is option D. Question number 82. In aluminothermite process, aluminium acts as, means we have to answer whether it is an oxidizing agent or reducing agent or both. So in aluminothermite process means aluminium, take an example Cr2O3. Aluminium is converted into Al2O3 and chromium oxide will be reduced into Cr. Since aluminium reduces Cr2O3, it acts as a reducing agent. Therefore, the answer is option C, that is reducing agent. Question number 83. Native silver reacts with sodium cyanide in presence of water. In presence of which of the following, that is nitrogen gas, oxygen gas, or CO2 gas or argon, it will form a soluble complex, that is NaAgCN2. That means we can say sodium dicyanoargenteate. Now silver and NaCN and H2O requires oxygen so that Na can be converted into NaOH. Therefore, out of these four, the oxygen gas is the important one which required to produces a soluble complex. Therefore, the answer is option B, oxygen gas. Question number 84. BF3, BCl3 and BBr3 is given, that is boron trihalides, and we have to write in the decreasing acidic nature, that means decreasing order of the acidic nature of boron trihalides. Now if you consider BF3, boron's octet is not completed, that means it is an electron deficient compound, and so it will show acidic nature. But in this case of BF3, all the 3F contain 3 lone pair each, and one of this lone pair can go for back bonding. That means F BF3, and this tendency of back bonding will be decreases down the group. Therefore, we can say that BF3, due to its back bonding of electrons by fluorine to the boron, it is less acidic and it is increases down the group. Since chlorine and bromine site is larger than boron, its back bonding will be difficult. Therefore, the acidic nature, so we have to write in the decreasing order. So we can write the highest will be BBr3, since Br atomic size is very large with respect to B. So we can write BBr3, then BCl3, then PF3. This will be the decreasing order of acidic nature of boron trihalides. Therefore, the answer is option B. Question number 85. We have to find the oxidation state of iodine in the compound H4IO6-. It is an ion, therefore we have to find the oxidation state of iodine. We know that hydrogen, its oxidation state in this is +1 and oxygen is -2. So we can write 4 into +1. We have to find for the iodine. So let us assume X is the oxidation state of the iodine. Oxygen -2, therefore we can write 6 into -2, and that is equal to the net charge, that is equal to -1. Therefore we can find X. It is equal to 4 plus X, -12 is equal to -1. Therefore X is equal to +7. That means oxidation state of iodine is +7. Therefore the answer is option A. Question number 86, we have to find the highest dipole moment out of the following, that is NH3, PH3, SbH3, ASH3. If you consider nitrogen, phosphorus, antimony and arsenic, the electron negativity of nitrogen is higher. Therefore, its dipole moment will be also highest. That means we can say down the group, this all are of the same group, and down the group electron negativity decreases, and therefore the dipole moment is also decreases. So we can say that NH3 will be the highest dipole moment. So the answer is option A. Now, which of the following metals will produces hydrogen gas on reacting with cold HNO3? There is only the two metals which will produces hydrogen gas. They are manganese and magnesium. These two only will react with cold HNO3 and will liberate hydrogen gas. Rest all metals will not liberate hydrogen gas. So the four options are given, according to which we can say the option B is the correct answer. Now question number 88. Given question is ammonium dichromate on heating. Ammonium dichromate on heating produces nitrogen gas plus Cr2O3 plus H2O. So these three are the product, N2, Cr2O3 and H2O. And there are four options are given, and you have to answer which of these options will produce same nitrogen gas. So the first one, ammonium nitrite on heating. Ammonium nitrite on heating produces N2 plus H2O. Second one, ammonium nitrate. On heating it produces N2O plus H2O. Third option, magnesium nitrite. On reacting with water produces magnesium hydroxide and NH3. Fourth one, H2O2 on reacting with sodium nitrite, it will produces NaNO3 plus H2O. Actually, first of all, this H2O2 decomposes into H2O plus nascent oxygen. This nascent oxygen further reacts with sodium nitrite and it is converted into NaNO3. Now out of the four options, option A produces nitrogen gas which is similar to the gas which is produced from ammonium dichromate. Therefore the answer is option A. Question number 89. There are four salts are given, that means four ions, Fe2 plus ion, CO2 plus ion, Mn2 plus ion and Pb2 plus ion. Which of the following will not show Borax bead test? So first of all you should write Borax bead test. This test is applicable only for the colored salts. So out of these four, the first three are the, check that Fe2 plus, CO2 plus and Mn2 plus are transition elements. Therefore their salts are colored. And this is non-transition element, that is Pb2 plus, and it is not a colored salt. So we can say that these two These three will show borax B test, and Pb2 plus will not show borax B test since it is a colorless salt. Question number 90, laboratory preparation of H2O2. Option A is given, MnO2 is reacting with coal and dilute H2SO4. H2O2 cannot be prepared by this reaction, so option A cannot be possible. Option B, BaO2 when react with CO2 in presence of H2O, it is converted into barium carbonate, BaCO3 plus hydrogen peroxide. So by this process we can produce hydrogen peroxide. Next one, PbO2 plus acidified KMnO4. Acidified KMnO4 will produce nascent oxygen, and this nascent oxygen can oxidize PbO2, but it cannot produce H2O2. So option C is also not possible. Option D, Na2O2, sodium peroxide when reacted with water, that is boiling water, it will produce sodium hydroxide and oxygen gas is liberated. So this method is also not applicable for preparation of H2O2, therefore the answer is option B.